You know their
prophecy
names.
foretold this.
You've seen their colossal skeletons in museums, their fearsome
Indeed,
silhouettes
the
burned into
ancient
your
beasts
imagination.
return.
The Tyrannosaurus rex, the Stegosaurus, the Triceratops. You imagine them as a bygone age, a world of primeval jungles and thunderous roars. But what if the story, you know, the one about a meteor and the end of a long, slow decline, is just one scene from a much bigger, much stranger, and far more mysterious play? Close your eyes for a moment. Picture the non-avian dinosaurs 66 million years ago. But don't imagine a dying breed slowly fading into obscurity. Imagine a thriving, powerful dynasty. A world where pterosaurs, the flying cousins of the dinosaurs, have already ruled the skies for 100 million years, and where in the oceans gigantic plesiosaurs and mosasaurs are hunting with the ruthless efficiency of creatures at the top of their food chain. This was not a world on its last legs. This was a world alive, full of life, and it was about to have the worst day in its history. This isn't just a story about the end of the dinosaurs. It's a story about the end of worlds. See, the dinosaurs aren't unique. The end of their reign was just one act in a recurring tragedy that has played out on Earth again and again long before we were here to tell the tale. It's a rhythmic pulse, a terrifying grand-scale reset button that the planet seems to hit every so often. And by the time we're done, you'll see that the final chapter of the story is not about what came before, but about what's happening right now in your own lifetime. You will never look at the history of life on Earth the same way again. You're floating in the inky black void of space, a silent, unseen observer. You watch as a magnificent blue marble, teeming with life, spins below you. Now let's travel back in time hundreds of millions of years. The planet below you is a very different place. The continents are scattered, life is confined mostly to the sea, and the air smells like the Earth is still just figuring things out. You see life, but it's alien to your eyes. The ocean floor is a carpet of bizarre, segmented creatures called trilobites crawling over ancient reefs. They've been here for tens of millions of years, an incredibly successful and diverse group. But in a geologically short amount of time, you watch as something terrible happens. The climate shifts dramatically. The planet gets cold. Very, very cold. Now, a quirky fringe tidbit. The end Ordovician extinction. The first of the Big Five was probably triggered by a period of extreme global cooling and glaciation. This wasn't like a regular winter. This was a deep bone-chilling freeze that sucked vast quantities of water out of the oceans and locked it up in immense ice sheets. You can see the sea levels dropping dramatically, like a bathtub emptying itself. And what happens when the sea floor is suddenly exposed to air? All that ancient, slow-moving marine life is left to shrivel and die in what must have been the longest, most agonizing beach day in history. An estimated 85% of all species vanished. The Ordovician extinction is a great example of something that historians still argue about. Was it the cooling itself that caused the death, or the cascade of secondary effects that followed? The consensus today points to the domino effect. The cooling triggered the glaciation triggered the sea level fall, and the sea level fall triggered the die-off. It's a pattern we'll see again and again, a single, powerful event, setting off a chain reaction that unravels the entire intricate tapestry of life. You can imagine the deep sense of wrongness, the planet shuddering as if it were trying to shake off an infection. It's a powerful, terrifying thought that the Earth itself has a way of resetting the evolutionary clock, a kind of biological do-over, no matter how much life has to pay the price. And that's just the first of the Big Five. Remember that initial chill from the Ordovician, the world shuddering as the ice sheets grew and the seas receded. Well, that was just the opening act. Over the next 400 million years, the planet would get a lot more practice at this. You see, these weren't isolated incidents. For all of its immense geologic calm, Earth is also a planet with a powerful hidden rhythm, a beat, that plays out in cataclysmic pulses. And we call those pulses the Big Five. Imagine a timeline stretching out before you. A seemingly endless, unbroken line of biological prosperity. But if you look closely, you can see 5 distinct jagged spikes where the line plummets, 5 moments where life on Earth took a near-fatal blow. These were not mere downturns, they were planetary-scale cleansings, each one a profound system-wide collapse. And the second one in this terrible series was the late Devonian extinction, around 374 million years ago. It's a perfect example of how an extinction doesn't have to be a single, sudden event. This was a long, slow-motion disaster that dragged on for millions of years, a series of compounding pulses that gradually silenced the seas. You're floating in a warm, shallow, ancient ocean. The water is a beautiful turquoise color, and below you a magnificent coral reef teems with life. Bizarre armored fish swim by looking like something out of a futuristic deep-sea fantasy. But as the centuries turn into millennia, you notice things starting to go wrong. The water gets murkier, and the reefs seem to shrink a little each year. The environmental changes are subtle. At first, fluctuations in sea level, a gradual reduction in oxygen and carbon dioxide, and alternating periods of global warming and cooling that would make any modern-day weather forecaster throw up their hands in despair. You'd just be sitting there like a tiny, prehistoric barnacle, thinking to yourself, my shell feels a little more acidic than usual, but I'm sure it's fine. It wasn't. This was a disaster by 1,000 cuts, not a single decisive blow. It's a bit like watching a slow-motion video of a beautiful sandcastle being washed away by gentle waves over and over again until there's nothing left. Around 3/4 of all species disappeared, and the great coral reefs of that era were wiped out. Trilobites, those ancient segmented bugs from the Ordovician, took another terrible hit with their populations, never fully recovering from the devastating loss. And this is a great example of an open, scholarly debate. Scientists still argue over the exact trigger for this protracted cataclysm. Was it a series of volcanic eruptions, a meteor, or was it something else entirely? We don't have a clear smoking gun for this one, just the grim, silent testimony of the fossil record. But as horrifying as the Devonian was, it was only a prelude. About 120 million years later, the planet was about to experience something far, far worse. The end-Permian extinction, some 252 million years ago, is known by another name, the Great Dying. And trust me, the name fits. If you could rewind time and watch this one, it would be the most terrifying thing you'd ever see. You would witness the very air and oceans becoming toxic. This wasn't a quick, merciful death for 85% of life. This was a planetary tragedy of unimaginable scale that snuffed out more than 95% of all species. 95%. Think about that number for a second. Only 5% of all life, from the tiniest creatures to the largest land vertebrates, survived. The land became a graveyard, the skies emptied, and the oceans, which had harbored life for billions of years, became a vast liquid tomb. The scientific consensus points to the most spectacular volcanic eruption in Earth's history as the culprit. You see in what is now modern-day Siberia, a series of immense, prolonged volcanic eruptions began to tear the planet apart. We're not talking about your average Mount Vesuvius here. This was a flood basalt province, a massive geological wound that covered a region the size of Australia. For millions of years, the volcanoes spewed colossal amounts of carbon dioxide and other noxious gases into the atmosphere. The gases triggered rapid global warming, but that was just the beginning. A quirky, stomach-turning tidbit: the increased atmospheric carbon dioxide also dissolved into the oceans, making them so acidic that the shells of marine life began to dissolve. The oceans became anoxic, meaning they lost most of their oxygen, and scientists believed the seas would have smelled of sulfur, like a planetary scale rotten egg. The Great Dying was a total unmitigated apocalypse, the ultimate wake-up call for life on Earth, and it's a wonder anything survived at all. Most land vertebrates vanished, and the once ubiquitous trilobites were finally, mercifully, completely erased from the planet after their long, slow decline. This event is proof that the planet doesn't need a cosmic-sized punch to the face to reset the clock. A long, slow exhalation of volcanic breath can do the trick just as well. But the story doesn't end there, because even after a planetary reset, that devastating life stubbornly finds a way. In the wake of the Permian extinction, a new world began to emerge. The new flora and fauna were still primitive, but they were the pioneers of the next great epoch. For a while, the planet was in a state of fragile recovery, and then about 50 million years later, it happened again. The end Triassic extinction, roughly 201 million years ago, was another colossal geological act with its own unique twist. Just like the Permian, this one was likely caused by massive volcanic eruptions that spewed carbon dioxide into the atmosphere, triggering a rapid spike in global temperatures and ocean acidification. It was a big deal. Around 80% of all species vanished. But here's the strange and paradoxical part. A small group of reptiles who had been living in the shadow of other creatures were left largely unscathed. This group would go on to inherit the Earth and rule for the next 180 million years. You guessed it. These were the dinosaurs. The selective nature of the Triassic extinction is something to ponder. You can't help but wonder why the dinosaurs were so lucky. Was it just random chance? Or did their specific body plans, their adaptations, give them a decisive edge in the face of this particular kind of environmental stress? We're still not entirely sure. But the fact remains that a global cataclysm, a terrifying repeat of the events that had just almost wiped out all life instead, cleared the way for a new, powerful lineage to rise and dominate the planet. And finally, of course, there was the last of the Big Five, the one that everyone knows, the one that ended the reign of those very same dinosaurs, the end Cretaceous extinction that happened 66 million years ago. It was this event that truly set the stage for the world as we know it today, clearing the way for the rise of a new group of creatures that had been hiding in the shadows for over 100 million years, us, the mammals. The geological record of the Big Five reveals a crucial and terrifying pattern. These weren't random, isolated events. They were junctures where Earth's systems reached a tipping point, a domino effect, where a single geological or cosmic trigger could initiate a chain reaction of planetary-scale environmental effects. A drop in sea level, a change in atmospheric composition, a spike in global temperatures, it all adds up and it all comes back around. It's a fundamental understanding of Earth's immense power and fragility. And it's what we need to keep in mind as we unearth the secrets of the last day of the dinosaurs. You've seen the rhythm now, that slow, terrifying pulse of death and rebirth that punctuates the planet's long, deep history. But to truly understand it, you have to go all the way back to the beginning, back past the Permian and the Devonian, past the Triassic, to the very first of the Big Five. The one that happened when the world was in so many ways still a baby, just figuring out its systems. Drift with me now backward in time, much farther than you've ever gone, The air around you thins and the colors of the world shift. You pass the moment of the dinosaurs, a blink in the eye of geologic time. You pass the great, dying, a fiery blur of volcanic clouds. You keep going, a silent ghost gliding through the epochs until you arrive at a world you would barely recognize. The year is approximately 447 million years ago. You are floating in an ancient ocean because that's the only place life is. The continents are not where you know them to be. They are scattered and drifting with a great supercontinent called Gondwana, sitting squarely over what will one day be the South Pole. The planet's air and oceans are much warmer than you're used to, a balmy tropical warmth that has lulled the life here into a slow, comfortable rhythm. There are no forests on land, only a few primitive plants starting to make a cautious home in the coastal mud. The oceans, however, are teeming. You look down and you see a world that is completely alien, like a garden of strange armored flowers. There are no fish as you know them, just their jawless, armored ancestors swimming awkwardly through the water. The seafloor is a bizarre carpet of life-bulbous, immobile creatures that look like they belong in a Dr. Seuss book. And everywhere a kind of ancient segmented bug. The trilobites crawl and scuttle, a dominant and wildly diverse family that has been the star of the show for eons. On the surface, you see delicate, feather-like creatures called graptolites floating in immense colonies, little plankton communities that are the bedrock of the food chain. And in the silence of deep time, a change begins. It's subtle at first, almost imperceptible. The sun feels a little less warm. The ocean currents seem to shift in an unfamiliar way. The planet is getting a severe case of the shivers, and it's about to plunge into a deep freeze. It starts with Gondwana, that great continent settled on the South Pole that begins to accumulate immense glaciers. Not just little ice caps, but vast continental-scale ice sheets. You can almost feel the temperature drop the air, losing its muggy warmth. And as the planet's water gets locked up in these immense glaciers, you can watch something terrible happen to the oceans. The sea levels begin to drop dramatically and with a quiet, relentless certainty by as much as 100 meters. You can imagine the shallow seas, the great continental shelves where all this bizarre life lives, simply receding. The coastline moves out, leaving millions upon millions of creatures to shrivel and die on the newly exposed land. It's the worst beach day in history, and the poor trilobites and brachiopods who have spent their lives in these calm, shallow waters are helpless as their world drains away. This slow, relentless environmental change is the ultimate villain of this story. Because as the oceans get colder, a second more sinister process takes hold. The frigid, oxygen-rich water from the newly formed polar regions sinks to the bottom of the ocean, creating a new, strong current that drives a circulation pattern you've never seen before. It stirs up the deep anoxic, meaning oxygen-depleted bottom waters. And what happens when those toxic, deoxygenated waters get pushed up onto the continental shelves? All those sea creatures who managed to survive the sea level fall are now suffocating in a silent, poisoned soup. It's a quirky and fringe tidbit, but this upwelling of toxic deep water is a testament to the intricate and often counterintuitive ways that Earth systems are connected. The cold, oxygenated water at the pole was so heavy that it became a global-scale engine driving a current that would ironically poison the oceans it was meant to be ventilating. It's a bit like buying an expensive air purifier that instead of cleaning the air just starts spewing out farts. It just doesn't make sense. And yet this is exactly what the science suggests happened. The final result of this long, slow catastrophe, around 85% of all species vanished. This was the first great cleansing, a moment that reset the biological clock and forever changed the course of life on Earth. All those trilobites, the silent stars of this alien world, took a terrible hit, with many of their lineages being completely erased. But unlike the end-Permian extinction that would follow, some trilobite species would survive this one, a testament to their resilience. And how do we know all this? We have the planet's testimony. Even today, if you were to trudge out into the desolate, sandy wastes of the Sahara Desert or the arid lands of Saudi Arabia, you could see the physical scars of this ancient freeze. Scientists have found something called glacial pavements, which are flat, rocky surfaces that show the scratches and grooves left behind by immense moving ice sheets. It's like a colossal version of a puckered-up road after a snowplow has gone through. They have also found striated pebbles rocks with telltale glacial scratches. But my personal favorite piece of evidence, the one that really sells the story for me, is the dropstone. These are massive rocks found in the fine marine sediment far from where any glacier would have been. They are a sign that icebergs, having calved off the great glaciers on Gondwana, floated for hundreds of miles before dropping their rocky cargo into the silent sea, just like a giant, icy boat losing its anchor in the middle of a calm pond. This is a great example of a kind of open, scholarly debate. Scientists still argue over what the ultimate trigger was for this ice age. Was it massive, prolonged volcanic activity? Was it a change in the planet's orbit? Or was it something even more strange and profound? Some researchers now believe that the rise of the first land plants, those primitive organisms that were just starting to make a foothold on the continents, may have had a catastrophic effect. By drawing carbon dioxide out of the atmosphere, they could have inadvertently contributed to the global cooling that would eventually lead to the extinction of so much of their oceanic kin. It's a tragic, ironic twist of fate, isn't it? A new life form taking its first breath on land, and in doing so, holding the final breath of the world it came from. This great icy catastrophe set the stage for a new epoch, a new world where a few resilient survivors could begin to rebuild. But it was not the last. The planet's pulse of death was just beginning. It would beat again 70 million years later, and this time, the death would not be brought by the cold, but by something much slower and much more sinister. The Devonian extinction was not an icy shock, but a slow sickness that would silence the seas. Remember that deep chill from the last section, that long, cold night when the world shivered and the seas dropped. That was a powerful, sudden shock, a punch to the face, from a planet that was in its own way still figuring things out. But the planet's terrible lessons don't always come in the form of a rapid freeze. Sometimes the end is not a sudden bang. It's a long, tragic series of whispers, a slow, agonizing sickness that works its way through the very veins of the earth until there's nothing left to whisper to. That's where you are now. Welcome to the late Devonian, about 375 million years ago. The planet has recovered from the Ordovician, and life is once again flourishing in the oceans. You're floating in a warm, shallow, tropical sea. It's a beautiful, sun-dappled world. Imagine the water is clear, and below you a magnificent coral reef is pulsing with life, a vibrant, living city of strange, hard-shelled creatures that look like something a very imaginative artist might have created. The oceans are full of bizarre armored fish, and the graptolites you saw before have given way to new, even more complex forms of life. The trilobites are still here, but they're not the unchallenged kings they once were. They're still a large and powerful family, but you can see that their numbers have been a bit thinned out since the last time you saw them. You almost feel a little sorry for them. This peaceful scene is about to be turned on its head but not in an instant. This extinction was a marathon, not a sprint unfolding in several waves over the course of millions of years. It's like watching a candle slowly burn down, but every time you think it's about to go out, a new draft of air catches it, and it burns a little longer, only to get a little closer to its end. You see, the Devonian extinction, which killed up to 3/4 of all marine life, was a slow-motion catastrophe driven by a series of compounding stresses. The scientific world has, for a long time, been trying to put its finger on the exact culprit. Was it a Comet A series of small impacts? The consensus was always a bit fuzzy, a bit mysterious. It was a classic, open scholarly debate, with scientists arguing for decades over what the main direct cause was, and for a long time, there was no single smoking gun to link this event to the others. We knew something terrible happened, but we couldn't see the wound. But the most recent scientific detective work, the kind of stuff that would make a paleontologist's heart flutter, has shed new light on this old mystery. The answer, it turns out, is a bit of a plot twist, and it points to a surprising and rather unsettling synergy. First, a quirky and truly fringe tidbit about this extinction. The ultimate trigger for the Devonian die-off was not just a geological event, but a biological one as well. For the first time in the planet's history, life on land was beginning to truly flourish. Primitive plants were evolving, growing deeper and deeper roots that were like a revolutionary new technology. These roots were great for the plants, anchoring them and helping them to survive on the land, but they also had a catastrophic side effect. As the roots broke down rocks more efficiently, they flushed an immense amount of nutrients and terrestrial sediments into the oceans. Now you might be thinking, what's so bad about that? Isn't more food a good thing? And you'd be right in a way. But in a closed system like the ocean, too much of a good thing is a very, very bad thing. The extra nutrients caused massive algal blooms, a kind of suffocating green tidal wave that bloomed and died, consuming oxygen as it decayed. This created vast zones of anoxia, that word you learned from the Permian meaning oxygen depleted, that were toxic to most marine life. It's a bit like giving a kid too many candy bars. It's great in the short term, but eventually you're just left with a screaming, hyperventilating mess. So you have this slow sickness taking hold, this gradual deoxygenation of the oceans, a biological innovation on land leading to a tragedy in the sea. But that wasn't the whole story. Because as modern scientists looked for a unifying factor, something to tie this extinction to the others, they found it. And it was exactly what they'd been looking for. It was a volcano, but not a single volcano. In a recent scientific study, researchers found a sharp, widespread pulse of mercury in rock layers from the Devonian period in places as far-flung as Morocco, Germany, and Siberia. This mercury, you see, is a geochemical fingerprint of volcanic activity. It's what you get when a massive volcano goes off, spewing a cocktail of gases and elements into the atmosphere that settle all over the globe. Mercury, it turns out, is to Earth-based catastrophes what iridium is to extraterrestrial ones. It's a silent chemical testament to a global event, and its presence provides the first clear evidence for a massive, prolonged volcanic event during this extinction. This discovery was the final elegant piece of the puzzle. Now scientists can say that all of the big 5 mass extinctions coincide with a major volcanic event. You have a terrible volcanic event spewing climate-altering gases into the atmosphere, causing temperature fluctuations and general planetary chaos. And at the exact same time, you have the rise of land plants, which is causing this slow, insidious deoxygenation of the oceans. It's the scientific equivalent of an aha moment, The modern understanding of the Devonian extinction is that it was not a single cause, but a perfect tragic synergy. It's a 1-2 punch of a different kind. You have a planet already under long-term stress from volcanism, its seas already struggling for breath from the influx of plant nutrients, and then a final devastating pulse of volcanic activity pushes it past its breaking point. This new model suggests that both factors, the long grinding geological shifts and the biologically driven ecological changes, were necessary for the mass extinction to take place. And what was the result? The beautiful coral reefs you saw at the beginning of this section were obliterated. All those intricate living cities of the sea were silenced forever. The trilobites, those tough, resilient little bugs, took another catastrophic hit, a blow so severe that their populations would never fully recover. The seas that had teemed with life for hundreds of millions of years fell silent, becoming a vast, watery tomb. The Devonian extinction shows you that the planet can die in a whisper just as easily as it can die with a bang. The lessons from the Devonian are a sobering observation when you think about our world today. We, with our vast agricultural runoff from fertilizers and our relentless combustion of fossil fuels, are creating a similar combination of stresses. We are flushing excess nutrients into our oceans and pumping climate-altering gases into our atmosphere. We are in our own way building the conditions for a repeat performance. The whispers of the past are a warning for the future. This slow sickness was a terrible, tragic end. But just like every other extinction, it was a moment of profound change. The planet would, in its own way, recover. But the next great dying, the one that would happen about 120 million years later, would be far, far worse. It was the largest and most devastating planetary tragedy of all. It was the Great Dying. You just experienced a slow underwater death, a protracted planetary sigh that silenced the seas. But as terrible as the Devonian extinction was, with its deoxygenated oceans and dying trilobites, it was only a prelude. It was the planet clearing its throat for the main event. What came next was a planetary tragedy of unimaginable scale. It was the moment that the world almost didn't make it. We're going to step on a very fragile piece of ground now, 252 million years ago. Welcome to the end of the Permian period, the boundary between an old world and a new one. The scientific community has a nickname for this event, and it's a chillingly accurate one. They call it the Great Dying. You can almost feel the weight of that name, the finality of it. This was not a selective pruning or a slow decline. This was an apocalypse. It was a tragedy so profound that it makes all the other great extinctions look like a friendly fire incident in a video game. Because in this one, a staggering 95% of all species on Earth just didn't wake up the next day. Now imagine you're standing on what will one day be the vast, lonely plains of Siberia. The sky is a weird, yellowish-brown haze, and the ground beneath your feet is trembling. Not with an earthquake, but with a deep subterranean rumble that feels like the planet itself is clearing a blockage from its throat. A massive volcanic event has begun an eruption so prolonged and so unimaginably huge that scientists have called it a singular event in Earth history that makes other eruptions look like a pinprick. This was not a single volcano. This was a volcanic province, a colossal geological wound that began to bleed out in a series of explosive pulses that lasted for hundreds of thousands of years. This isn't the kind of volcano you see in movies with a big plume and a fiery flow of lava you could outrun in a very fast car. We're talking about an outpour of magma so massive it was enough to cover a region the size of the United States in a layer of rock a kilometer thick. You would have been standing there maybe as a small lizard-like creature, watching as rivers of molten rock silently flowed across the landscape, burying everything in their path. You could maybe outrun the lava, but you couldn't outrun what came next. The real killers here weren't the fires or the lava flows. They were the gases. These Siberian traps spewed a planetary-scale cocktail of carbon dioxide and other greenhouse gases into the atmosphere, so much so that it completely and fundamentally disrupted the carbon cycle of the entire planet. The planet started to warm and warm fast. And just like with the Devonian extinction, this wasn't just a simple case of the temperature going up. It was a chain reaction, a terrible domino effect that made the entire world toxic. First, the rising atmospheric carbon dioxide began to dissolve into the oceans. This is the quirky fringe tidbit of the story that will make your skin crawl. You see, the oceans became so acidic that the shells of marine life began to dissolve. Imagine a world where the water itself is so corrosive that if you were a tiny shellfish, your home would just slowly melt away from you. But it gets worse, because the oceans were also getting warmer, and warmer water holds less dissolved oxygen. And at the exact same time, the metabolism of the marine life that had managed to survive was increasing in the heat, so they needed more oxygen. It was a truly unfortunate combination. You're baking in a stifling hot room and someone turns off the air conditioning and tells you that you need to run a marathon. It's a bad, bad time. This led to a widespread oceanic anoxia, a complete and total deoxygenation of the oceans, but with a new, much more horrifying consequence. Scientists believe that with the oceans starved of oxygen, a new kind of bacteria began to flourish, one that gave off a poisonous gas as a byproduct. The oceans would have smelled of sulfur like a planetary-scale rotten egg, with a toxic stench rising into the air, poisoning everything. This was the true silent horror of the Great Dying, not a quick, merciful blow, but a long, slow suffocation. The result was almost absolute. All trilobites, those ancient segmented bugs that had survived for hundreds of millions of years, were finally, mercifully, completely erased from the planet. The marine world you saw in the last section, with its strange, beautiful creatures, was almost entirely wiped clean. The devastation extended to the land as well, with the most land vertebrates, the ancestors of the dinosaurs, disappearing forever. And this brings us to a point that historians and scientists still argue about. Was it the global warming, the ocean acidification, or the anoxia that was the primary kill mechanism? The truth, it seems, is that it was all three. It was a grand, terrible synergy, with each factor making the others worse. The Permian extinction shows us that the planet can die by 1,000 cuts just as easily as it can by one sudden blow. It also shows us that even after a disaster of this scale, a small, stubborn sliver of life, that last resilient 5% will find a way to survive and to begin again. And that's exactly what happened. In the wake of this planetary horror, a new world began to emerge. A new cast of characters, the survivors of the Great Dying, began to multiply and spread, filling the empty, silent niches of the new world. It was a world that had just been through the worst it could ever face, and it was now a blank canvas, ready for the next great act of life. And the star of that act would be a new kind of reptile, a group that would inherit the Earth and rule for the next 180 million years. You're about to meet them. You've just borne witness to the largest planetary tragedy in the history of life, a terrifying moment when the world itself became a graveyard. The silent, suffocating oceans, the acid rain, the sky turning a sickly yellow-brown from volcanic gas. It was, in every sense of the word, an apocalypse. But even after the great dying, with a mere 5% of life left to inherit the ruins, the planet wasn't done with its rhythm of death and rebirth. You're now moving forward through time again, not by millions of years, but by tens of millions. The world is recovering slowly, painstakingly, but you can feel it. The air is cleaner, the sky is bluer, and the land, once a desolate, barren wasteland, is once again a palette of vibrant greens and browns. The survivors of the great dying, a strange and eclectic crew, are beginning to flourish. You see early mammals, tiny and scurrying, hiding in the shadows. But the stars of this new show are the reptiles. They're a different kind of reptile, a more advanced form that has a spring in their step and a hungry look in their eyes. This new world, this fresh canvas, is their opportunity. And then about 50 million years after the great dying, something eerily familiar begins to happen. The earth starts to rumble again, not with a sudden bone-shattering cataclysm like an asteroid, but with a deep, grinding groan from within its core. This, you realize with a sinking feeling, is another extinction event. This is the end of the Triassic period, a new kind of cleansing that happened about 201 million years ago. The culprit, just like the Great Dying, was likely a series of colossal volcanic eruptions, a new wave of planetary-scale geological flatulence that made the air unbreathable and the seas acidic. This time the volcanoes were tearing apart the supercontinent Pangaea, creating a new rift valley that would one day become the Atlantic Ocean. You can imagine the immense geological force, the slow-motion tearing of a continent, and the volcanoes that spewed forth as a result. They pumped a new wave of climate-altering gases into the atmosphere, causing global temperatures to spike and the oceans to turn toxic all over again. And the result was, in its own way, devastating. This extinction eliminated approximately 80% of Earth's species, with many marine invertebrates and even some early terrestrial vertebrates simply vanishing from the fossil record. The world, which had just spent tens of millions of years rebuilding from the great dying, was once again put on its knees. It's like a person who's just finished rebuilding their house after a devastating fire, only to find that the local utility company has decided to flood their neighborhood with acid. You can almost feel the cosmic sigh of frustration. But here's the most fascinating and paradoxical thing about the end Triassic extinction. While it was a catastrophe for most of the life on Earth, it was for a very specific and very lucky group of creatures the best thing that had ever happened. Because you can look at the fossil record and see that while 80% of species were wiped out, a certain group of reptiles was left largely unscathed. That group, as you can probably guess, was the dinosaurs. Now, this is where it gets interesting, and it's a point of open scholarly debate. Why them? Why were the dinosaurs so lucky? Scientists still argue over what made them so uniquely resilient to this particular kind of climate catastrophe. Was it their physiology? Their size? Their diet? We don't have a clear answer. The fossil record shows a gradual decline in many other species of reptile that were competing with the dinosaurs at the time. Perhaps the dinosaurs were simply better equipped to handle the rapid temperature fluctuations or the changes in the food supply that came with the climate chaos. It's a bit like a job interview where every other candidate either forgets their resume, shows up in a clown suit, or just starts screaming about their past traumas. And the dinosaur, by simply showing up and not self-destructing, gets the job. And what a job it was. The end Triassic extinction, by eliminating a majority of the dinosaurs' competitors, essentially cleared the way for them. It created an immense ecological vacuum, a planet-sized opportunity. And as the planet began its slow, inevitable recovery, the dinosaurs were the ones who were in the best position to take over. This is the great, strange lesson of this extinction. A global catastrophe can, in a strange twist of fate, pave the way for a new form of life to rise to dominance. The extinction was a selective agent of change, a crucible that created the perfect conditions for a new, powerful lineage to emerge. The death of the many gave birth to the reign of the few, and that reign would be a long, glorious, and unchallenged one. You can imagine them now stepping out onto this new, empty stage. The skies are quiet without the pterosaurs who were not so lucky in this extinction. The lands are quiet without the large terrestrial amphibians and other reptiles that had been dominant. And the dinosaurs, once a quiet, unassuming part of the planet's fauna, were now the kings of the world. They would go on to evolve into a stunning variety of forms, from the long-necked giants that fed from the trees to the ferocious predators that stalked the land. Their reign would last for the next 180 million years, a testament to their resilience, and perhaps to the lucky twist of fate that granted them a pass on the end Triassic. And it is this world, the one the dinosaurs inherited, that brings us to the final, most well-known chapter in this story. The one that for so long was the only one we knew. The one that ended their reign and paved the way for ours. The one that began with a peaceful, calm day on a world of giants. A day that was about to have its worst and final moment. You have seen the planet endure the fire and the ice, the slow sickness, and the sudden, silent suffocation. You have watched life wither and then stubbornly return, a testament to its tenacity. And in that last extinction, the end Triassic, you saw a group of reptiles get a lucky break, inheriting a world with all their major competitors gone. For 180 million years, they took that opportunity and ran with it, evolving into a dizzying array of forms. They would become the greatest dynasty of creatures to ever walk the earth. And now you are there, a silent observer in their kingdom. Close your eyes again. The air feels different here. It is a world of immense, living green, a humid, hothouse world with an endless, deep green forest that sprawls in every direction. The scent of ferns and rich, loamy earth is heavy in the air. The light filtered through a million leaves is dappled and golden. But what truly makes this world alien is the scale. You, a tiny human, are a speck in a world of giants. This is the late Cretaceous, a few weeks, a few days, a few breaths before the final moment of the dinosaurs. You are standing in the shadow of a truly immense creature. Its skin leathery and thick as a canvas of muted grays and greens. The ground trembles with every step as it forages its long neck reaching into the canopy of a giant tree. This is a sauropod, a long-necked herbivore, the kind of living, walking skyscraper that would have made you feel wonderfully, terribly small. The largest of these creatures, like the Argentinosaurus, had passed millions of years earlier, but even now the planet is a canvas for titans, a kingdom where size is a sign of power and a mark of success. The iconic dinosaurs, you know, are very real here. Not far from you, a great armored beast with a bony frill and a trio of horns is trundling through the undergrowth. This is Triceratops horridus, an 8-ton ceratopsian that looks like a war machine brought to life. It is the kind of animal that a predator would think twice about. And speaking of predators in the distance, you hear it. A deep, guttural roar that seems to vibrate in your very bones. You feel an instinctual, primal fear, the kind that tells you to run, to hide, to simply cease to exist. That roar belongs to the most famous of all the predators, the great Tyrannosaurus rex, a 9-ton theropod with a head full of teeth and a gaze that would freeze your blood. And yet, for all of its legendary status, T-Rex was not the largest of its kind. That title belonged to the massive semi-aquatic Spinosaurus, a semi-aquatic giant that hunted with crocodile-like jaws. The world is not a simple, monolithic landscape of these giants. In the skies, immense winged creatures soar on leathery wings. These are the pterosaurs, not dinosaurs, but their flying cousins, and they have ruled the skies for 100 million years. They are the majestic flying monarchs of this world, and you can see them dipping and gliding on the thermal currents. And in the oceans, a different kind of terror lives. The colossal mosasaurs and plesiosaurs living torpedoes of muscle and scale hunt in the sunlit shallows and the inky depths. Their existence is tied to the delicate balance of this living world. As you stand there, a silent witness to a moment of supreme majesty, a quiet thought begins to form. How can a world so vibrant, so powerful, so diverse just end? The answer, as you now know, is never a simple one. The planet was, in a very subtle way, already sick. It was a kind of planetary indigestion that had been brewing for tens of millions of years. In what is now modern-day India, a massive series of volcanic eruptions had been taking place in an area known as the Deccan Traps. It was a slow-motion geological catastrophe that spewed immense quantities of sulfur and carbon dioxide into the atmosphere, subtly stressing the global ecosystem, causing a climate that would swing wildly from cold to hot. You can imagine the dinosaurs, the giant plants, and all the other life forms on Earth trudging through their days, utterly oblivious to the long-term, slow-burn climate chaos that was being caused by something so far away. It's a bit like living in an apartment building and complaining about the smell of a neighbor's cooking, only to find out years later that their cooking was literally toxic and was slowly making you ill. This long-term, slow-burning stress is what historians still argue about. Was the volcanic activity a significant factor in the extinction, or merely a background noise to the main event? The consensus has always been that it was an appetizer, a stressor that was preparing the world for the main course. And that main course was already on its way, a silent, unseen threat, hurtling through the cold, dark emptiness of space. And it was coming fast. A massive, silent piece of rock, a relic from the formation of the solar system, is hurtling toward the planet. Its diameter is somewhere between 10 and 15 kilometers a size that is almost impossible to imagine in human terms. To give you some perspective, that's roughly the size of Mount Everest turned on its side. Now imagine a mountain larger than any you have ever seen hurtling towards you at a speed of over 25 kilometers per second. It is a silent, unfeeling force, a cosmic bullet that has been traveling for billions of years with no specific target, and it is about to hit the planetary bullseye. You watch from your unseen vantage point, a ghost in time. You can see the great continents below you, all the magnificent creatures that have fought and evolved for over 180 million years. The peaceful, oblivious giants of the Cretaceous, the flying rulers of the sky, the titans of the deep. And in the silent, empty void of space, you see the approaching threat, a small, dark speck that will in a moment become a point of brilliant, searing light. The dinosaurs, of course, have no idea. Their world, for all its power and its majesty, is about to have the ultimate bad day. A day that would, in the blink of a geological eye, change everything. A day that would erase a dynasty and clear the way for a new one. A day that for some would be a final, cataclysmic end, and for others the start of an entirely new beginning. You have just lived in the world that was about to die. And now you are about to watch it happen, the last breath of a prehistoric giant. You have seen the world of the dinosaurs, a living, breathing kingdom of giants. You have felt the warmth of its air and the subtle tremble of the ground under the feet of its colossal inhabitants. You've even noticed the quiet, insidious stress that was building from the volcanoes far away. And now, as you stand as a silent ghost in this ancient world, the silent, invisible threat you saw in the last section has arrived. Far up in the sky, a tiny, almost imperceptible point of light, no brighter than a distant star, begins to grow. It's a trick of perspective. It's not growing, it's approaching, hurtling toward the planet at a speed of over 25 kilometers per second. It's a cosmic bullet, a rogue rock that has been traveling through the cold emptiness of space for billions of years, and it is now about to strike. You watch as the point of light grows brighter, then brighter still, until it becomes an impossibly brilliant, searing point of fire, a new sun that outshines the real one. There is no warning, no slow, ominous approach, just a sudden, shocking incandescence that fills your entire vision, a blinding light that seems to erase the sky itself. And then there is the sound. It is a roar beyond comprehension, a sound that is not just heard, but felt, a low subsonic rumble that seems to vibrate in your very bones. It is the sound of a rock, roughly the size of Mount Everest, hitting the earth. The impact is not a collision in the sense that two cars hit each other. It is an instantaneous vaporization, a moment so violent that the colossal object turns to gas and fire in a nanosecond, blasting a gaping 150-kilometer wide wound in the planet's surface. The force of the strike is the equivalent of an earthquake of magnitude 10 or 11, a planetary punch, so powerful that it creates a scar that can still be seen today. The impact occurs not on a landmass, but in a shallow ocean near the coast of what is now the Yucatan Peninsula in Mexico. And that's a key detail, a truly quirky and chilling tidbit of fate. Had this asteroid, this great, unfeeling cosmic bullet, arrived just minutes later, it would have landed in deeper water. Had that happened, it might not have vaporized as much of the planet's surface, and it might not have led to a mass extinction. But it didn't. It hit a shallow ocean that was rich in a rock called gypsum, a sulfate containing rock that was about to become the planet's silent final poison. From the point of impact, two deadly invisible phenomena radiate outward. The first is a colossal blast wave, a supersonic shock front that races across the land and sea-leveling forests and incinerating everything in its path. You can almost feel the rush of air, a hot wind so fast and so powerful that it simply tears the world apart. This is followed by a heat wave of such intensity that it burns living trees at temperatures exceeding 1,000 degrees Celsius, igniting fires that will rage globally. The second is a colossal megatsunami, a wave unlike any in modern history that rushes inland with a speed and power that carries sediment, trees, and debris far beyond the shorelines. It is a wave made not of water, but of death and destruction, a wall of liquid mud and fire that consumes everything in its path. The immediate destruction is terrifying and absolute. In the immediate vicinity of the impact, life is simply erased in a flash of blinding light and heat. But as a ghost, you can see the secondary effects. You can see the charred trees and the debris, a silent testament to the fires that raged globally. And you can see the thick, chaotic layers of sediment that were deposited by the megatsunami which entombed millions of creatures in a geological time capsule that would one day be a treasure trove for paleontologists. This rapid burial of organisms, a kind of death by instant entombment, is a detail that historians still argue about. How exactly did this rapid burial happen? Did the seismic shock of the impact liquefy the ground, causing it to collapse like concrete? Or was it the massive tsunami that simply buried everything in its path? The exact mechanism is a point of open scholarly debate, and the evidence seems to support both. The asteroid itself was not the sole cause of the extinction. The real killer was the chain reaction it set off. The impact by vaporizing the sulfate-rich rock of the Yucatan injected hundreds of billions of tons of sulfur dioxide into the atmosphere, a poison that would go on to be a key element of the long-term devastation. The world, in a very real way, was about to choke on its own last breath. The silent, suffocating darkness you saw in the last section was about to become very, very real. The dinosaurs, for all their power and their majesty, had no defense. There was no running from a planet-sized shockwave, no hiding from a global heat wave. Their long reign was about to end, not with a whimper, but with the most spectacular, terrifying bang in the history of the last 100 million years. This was the moment that would define the rest of their story. The last day of the dinosaurs had begun. And the next chapter of this story is about what happened when the fires faded and the darkness began to fall. The blinding flash, the roar that shook the earth, the feeling of a world being torn apart, that was only the beginning. That was the first terrifying breath of a planetary-scale disaster. It was the sudden, catastrophic punctuation mark at the end of an era. But as you watch from your silent, unseen vantage point, you realize the real horror was not the immediate violence. It was the slow, insidious quiet that came after. The death of the dinosaurs was not a quick, merciful snap. It was an agonizing, drawn-out suffocation. Imagine, if you will, the immense, unthinkable amount of debris, vaporized rock and ash, that was thrown into the atmosphere from the impact. It was a quantity so vast that it created a colossal, planet-spanning cloud, a dark and impenetrable shroud that began to wrap the entire globe. You can watch as the sky darkens, a perpetual starless twilight that swallows the sun. It's like a permanent cosmic eclipse that just doesn't end. You're in a world without sunlight, a cold gray realm where the only light is the faint glow of the stars and the flickering distant fires of the burning world below. It's the ultimate solar punk nightmare, but instead of building a better future, everyone's just standing around trying to figure out what to eat for dinner. For life on Earth, this was a death sentence. The sun, as you know, is the foundation of almost all life on Earth. From the towering trees to the most delicate of flowers, every living thing relies on photosynthesis to create energy. But with the sun blotted out, photosynthesis simply ceased. You can feel it, the silent, agonizing death of the primary producers. The plants, the foundation of every terrestrial food chain, began to die off their leaves, withering, their stems collapsing. This wasn't a quick death. It was a slow, agonizing starvation that would ripple through every single ecosystem. The herbivores, those magnificent plant-eating dinosaurs that you saw just moments ago, were now left with nothing to eat. And with the herbivores gone, the carnivores, like the mighty Tyrannosaurus rex, were next to fall. It was a planetary-scale collapse, a grand, tragic undoing of a system that had been millions of years in the making. The darkness was not the only poison in the air. The colossal heat wave from the impact also ignited global-scale wildfires. You could see the scars of them, immense swathes of the planet's surface turning into a hellscape of fire and smoke. And all that soot, that black, thick, oily dust from the burning forest was carried up into the atmosphere where it only served to make the darkness more profound and more long-lasting. It was a terrible synergistic effect, a planetary-scale self-sabotage where the very act of survival, the burning of what was left, was only making the chances of long-term survival that much worse. And then there was the water. Remember that chilling, quirky tidbit from the last section. The fact that the asteroid hit a shallow ocean, rich in a rock called gypsum. Well, this turned out to be the ultimate devastating twist of fate. When the asteroid vaporized the rock on impact, it didn't just throw up dust and soot. It injected hundreds of billions of tons of sulfur dioxide into the atmosphere. When that gas mixed with the water vapor in the atmosphere, it created a highly acidic rain. You could imagine the drops falling a cold, burning liquid that would scald the remaining plant life and pollute every river, lake, and stream. The air would have smelled of sulfur like a planetary-scale rotten egg, with the acidic rain turning the world into a kind of chemical wasteland. It was the worst kind of surprise party where the cake is just a giant glob of toxic sulfuric acid. And the acid rain didn't stop there. It began to fall into the oceans, causing a widespread and deadly ocean acidification. This was another nail in the coffin. The pH of the oceans dropped, making it impossible for organisms with carbonate shells like plankton and mollusks to survive. You can't help but feel a certain sense of terrible irony here. The very geology of the planet the rock it was made of was used as a weapon against it, a silent, deadly poison that would choke the very life out of its seas. The collapse of the food chain, which began with the plants on land, was now mirroring itself in the oceans, where the tiny shell-building creatures at the base of the food web were just dissolving. It's like a planetary-scale, slow-motion version of that scene from the Wizard of Oz where the Wicked Witch of the West melts, but it's a million, billion tiny creatures melting instead. The story of the KPG extinction, as you can see, is not just about a rock from space. It's about a cascade of interconnected events, a profound and comprehensive ecological reset. The asteroid was just the starting gun. The real kill mechanism was the series of events it set off: the fires, the dust cloud, the darkness, the cessation of photosynthesis, the acid rain, and the global collapse of the food web. This is why a localized impact could become a global cataclysm, a profound and comprehensive ecological reset. It's a powerful lesson in planetary feedback loops, demonstrating how a single point of disruption can send ripples of destruction across the entire globe, affecting all life from the smallest microorganisms to the largest animals. This is also a place where you can see a truly open scholarly debate. Scientists still argue over the relative importance of these different kill mechanisms. Was the darkness from the dust cloud the most important factor? Or was it the long-term effects of the acid rain and the resulting ocean acidification? Was it the fires, or was it the fact that the asteroid hit a planet that was already under long-term stress from the Deccan Traps volcanism, making it more vulnerable to the final blow? The answer, as is often the case in science, is probably a combination of all of the above, a terrible synergistic mix of both a long-term, slow-burning stress and a sudden catastrophic final blow. The dinosaurs, for all their power and their majesty, had no defense. There was no running from a planet-sized shockwave, no hiding from a global heat wave. Their long reign was about to end, not with a whimper, but with the most spectacular, terrifying bang in the history of the last 100 million years. This was the moment that would define the rest of their story. The last day of the dinosaurs had begun. And the next chapter of this story is about what happened when the fires faded and the darkness began to fall. You've witnessed the impossible now. You've seen a world, a beautiful, vibrant tapestry of life torn apart in a single, catastrophic moment. You have seen the flash, the roar, and the silent, suffocating darkness that followed. It feels definitive, doesn't it? An asteroid the size of a mountain strikes the Earth. Of course, that's what killed the dinosaurs. It's such a clean, cinematic story. A single powerful punch that knocks the whole world out. But what if it was only half the story? What if the planet was already in the final throes of a long, slow sickness before the asteroid ever arrived? What if the final cosmic blow landed on a world that was already on its knees, gasping for its last breath? The scientific community has a name for this other theory, and it's a powerful and long-contested one, the volcanic counterpoint. You see, at the very same time, the asteroid was hurtling through space, and the dinosaurs were trundling along in their kingdom. A massive series of volcanic eruptions was taking place in what is now modern-day India. We're not talking about your average run-of-the-mill Mount Vesuvius here. This was a volcanic province, a colossal geological event, known as the Deccan Traps, that buried a vast portion of the subcontinent under more than 11,000 feet of lava. It was an eruption on a scale that is almost impossible to imagine, and it had been going on for hundreds of thousands of years before the asteroid ever made its grand entrance. The Deccan Traps were a slow, burning catastrophe, a planetary-scale source of poison that was already filling the skies with dust and gas. The proponents of this theory, a school of thought that has long vied for supremacy in the dinosaur wars, argue that this immense volcanic activity alone was the primary driver of the extinction. The eruptions pumped trillions of tons of carbon dioxide and sulfur into the atmosphere, creating a climate that was in constant terrifying flux. The gases would have caused periods of global warming, then global cooling, making it impossible for ecosystems to adapt. It's like living in a house where the furnace and the air conditioner are both stuck on, and you're just constantly trying to find a corner of the room where you won't freeze or roast. For life on Earth, this was an unbearable long-term stress. And here's a quirky and fringe tidbit that makes this a truly fascinating story. One of the leading critics of the asteroid hypothesis, a geologist named Gerta Keller, has spent decades arguing that the asteroid impact was just a sideshow. Her research suggests that the asteroid may have hit the Earth 200,000 to 300,000 years before the actual extinction event. You can almost hear her saying to the asteroid proponents, "Nice try, but your timing is a bit off." She argues that a time gap that large is too big for a direct correlation, and that the long-term devastating effects of the Deccan Traps were the real culprits. She points to the fact that a number of tiny, resilient species in the oceans survived the asteroid's initial blast, only to die off later in the climate chaos caused by the volcanoes. It's a compelling, if controversial, argument, and it brings us to a deep and fundamental, open, scholarly debate in the field of paleontology. Which one was it? Was it the asteroid or was it the volcano? For years, the debate was an acrimonious one, a classic scientific standoff, with two powerful theories fighting for dominance. One side had the smoking gun of a planetary-scale impact. The other side had a long-term, slow-burn geological process that could explain the long, drawn-out decline of some dinosaur species in the fossil record. But as with so many great debates in science, the answer turned out to be not an either-or, but a more complex and nuanced both-and. The most recent scientific research, including some that use machine learning models to analyze thousands of possible scenarios, has pointed to a powerful synthesis, the 1-2 punch hypothesis. The planet, it seems, was already under immense environmental stress from the sustained long-term volcanic activity of the Deccan Traps. The eruptions had been ongoing for hundreds of thousands of years, causing a period of climate instability that was already making life difficult. In this model, the Chicxulub asteroid did not strike a pristine world. It delivered the final catastrophic blow to an already reeling ecosystem. It was the perfect, terrible coincidence of a long-term internal disaster meeting a sudden external one. The volcanoes weakened the world, and the asteroid finished it off, So when you think about the last day of the dinosaurs, don't just picture the single fiery rock that plunged from the sky. Picture a world already groaning under the weight of a long, slow sickness. Picture the sky already a sickly yellow from volcanic gases. Picture a planet that was ready for the ultimate reset. The end of the dinosaurs was not just one story. It was two of the most powerful forces on the planet, one internal, one external, converging to create a moment of extinction that will never be forgotten. And in that empty, quiet world, a new cast of characters, the survivors, was about to take the stage. You've seen the pieces of the puzzle now. You've seen the smoking gun of the asteroid impact the eerie worldwide layer of iridium, the buried crater in the Yucatan, and the fossilized evidence of a world that went dark and cold. It's a compelling, straightforward narrative, a single terrifying act that ended a dynasty. But you've also seen the other side, the long, slow-burning catastrophe of the Deccan traps, the volcanoes that spewed a planet-sized cocktail of climate-altering gases into the atmosphere for hundreds of thousands of years. It's a lot to hold in your head at once, isn't it? A single, sudden cosmic blow and a long, relentless, subterranean exhalation. Which one was it? Which one was the real culprit? For decades, this was the central question that divided the scientific community. It became an almost legendary battle, a long-running, acrimonious debate that was so intense it was affectionately, or perhaps sarcastically dubbed, the Dinosaur Wars. Scientists, in what was a genuinely open scholarly debate, dug in their heels on both sides. The Alvarez team and their supporters pointed to the undeniable evidence of the impact, the iridium, the shocked quartz, the tektites. How could a long, drawn-out volcanic event explain such a sudden, cataclysmic end? Their opponents, a group led by the staunch and vocal Gerta Keller, countered with the timing of the Deccan traps. They argued that the sheer volume of volcanic gases alone was more than enough to trigger a mass extinction, and they questioned whether the asteroid impact was even at the right time. For them, the long decline of the dinosaurs in the fossil record pointed to a long-term systemic stress, not a single sudden blow. It was a classic either-or question, a binary choice that seemed to demand one definitive answer. But science and the planet, as you've seen, rarely provides a simple, clean narrative. The more we learn, the messier the story becomes, and the more we peel back the layers of this ancient catastrophe, the more it becomes clear that the final answer is not a simple either-or, but a complex and deadly both-and. The most recent scientific consensus, a beautiful synthesis of both theories, is called the 1-2 punch hypothesis. You can almost hear the planet sighing and saying, why not both? Imagine, if you will, a powerful boxer in the final rounds of a fight. They have been battered and bruised, but they are still on their feet, still fighting, still in the game. That was the world in the late Cretaceous. The long-term, slow-burning, climate-altering eruptions from the Deccan traps had been a relentless series of jabs and body blows. They had been pummeling the planet's ecosystems for hundreds of thousands of years, causing a period of climate instability with frequent swings between cold and hot periods. Many dinosaur species were already on a slow decline, stressed and weakened by a world that was becoming increasingly difficult to live in. The planet was already tired. It was already reeling. It was ready for the final decisive blow. And that's exactly what the Chicxulub asteroid delivered. It wasn't the first punch, but it was the knockout blow. It struck a world that was already teetering on the edge of ecological collapse. The long-term stress of the Deccan traps, the subtle changes to the atmosphere and oceans had made the world exquisitely vulnerable to a sudden catastrophic event. A quirky fringe tidbit that perfectly illustrates this modern consensus: a recent study used machine learning, a type of artificial intelligence, to sort through over 300,000 possible scenarios of volcanic emissions and biological productivity to figure out what happened. They essentially let a computer decide what the most likely scenario was. And the computer found that the Deccan traps alone could have been sufficient to trigger the extinction. But here's the key. The model also found a sharp, undeniable drop in the accumulation of organic carbon in the deep ocean, precisely at the time of the impact, a clear signal that the asteroid, and not the volcanoes, was responsible for a unique catastrophic collapse of the global food chain. It's like finding a single decisive piece of evidence that links a long-term serial killer to a single final murder that was the last nail in the coffin. It's the perfect tragic marriage of two separate and devastating catastrophes. So when you picture the end of the dinosaurs, don't just imagine the single fiery rock that plunged from the sky. Picture a world that was already sick, a world that was already on a slow decline. Picture the planet battered by centuries of fire and ash, receiving its final, terrible blow. The end of the dinosaurs was a tragic and profound convergence of two of Earth's most powerful forces, the deep internal rumblings of volcanism, and a sudden external strike from the cosmos. The extinction was a tragic symphony of destruction played out over a long, terrible period of time. The end of the age of reptiles was a great global reset, a planetary-scale cleaning that wiped the slate clean for a new chapter to begin. The world was now empty. The great niches once occupied by the dinosaurs, the pterosaurs and the mosasaurs, were now open. And the survivors, the small scurrying creatures that had lived in the shadows for over 100 million years, were about to take the stage. Our journey through deep time now brings us closer to the present. You are leaving the world of the ancient reptilian giants and entering the world of a new kind of behemoth. These creatures look much more familiar to you. They are not covered in scales, but in thick, shaggy fur. And they did not die out from an asteroid or a volcano. They died at the hands of a new kind of force, a new and in many ways more frightening kind of predator. The next chapter of this story is about the rise of the mammals and their last great stand against a force that would change the world forever. The great dinosaur kingdom, that long-lost world of scaly titans, had crumbled into dust and ash. The planet, still recovering from its great fever, was a blank slate. You can see it in your mind's eye. The sun is now shining again, but the light is different. It's a quiet, tentative kind of light, a soft, pale gold that shines down in a land that is mostly empty. The long, silent night that followed the asteroid impact gave the remaining life a chance, and in the shadows scurrying in the quiet corners of the world, a new class of creatures began to stir. They were small, timid, and furry. They'd been living in the background for over 100 million years, hiding from the great lizards, waiting for their moment. And now, with their primary predators gone and the great ecological niches of the world completely empty, they were free. The mammals were about to get their turn. They were about to step out of the shadows and grow into something magnificent, something that would rival the very giants that had come before. And so we travel forward, a ghost gliding through the epochs, past the early timid days of the Cenozoic, past the time when the largest mammals were the size of dogs, and a new kind of world is beginning to emerge. This is the late Pleistocene, a period that began about 2.5 million years ago and ended just 11,700 years ago at the close of the last great ice age. The continents are in the positions you know them to be, but the climate is a different story. This is a world of ice, a cold, magnificent landscape dominated by a spectacular array of immense animals known as megafauna. These were the last true giants of the planet, and they were the ancestors of many of the animals you know today. You can feel the sharp bite of the wind, smell the cold, damp scent of snow, and see the vast rolling plains of ice and tundra that stretch out to the horizon. The world is built for endurance, for thick hides and shaggy fur, for immense reserves of fat and a slow, methodical pace. Imagine walking through these vast frozen tundras of Eurasia and North America. You're not going to see any deer or elk here, no. You see something much, much bigger. You hear them before you see them, a low rumble that vibrates through the earth, a sound like a distant rumbling thunder. It's a herd of shaggy, immense creatures. This is the woolly mammoth, a 10-ton behemoth of muscle and bone. They roamed in great herds, their curved tusks acting as giant rakes to clear the snow for the grasses and sedges that lay beneath. Their long, shaggy coats were like a kind of built-in winter parka, making them perfectly adapted to the cold. They were the kings of this frozen world, silent, majestic, and powerful. A close cousin, the steppe mammoth, was even bigger, but we don't have a clear idea of what it looked like because no quick frozen specimens have been found, unlike its more famous cousin. It's a bit like trying to describe a celebrity from their Twitter profile picture. You get the gist, but you don't have the full picture. And speaking of size, there was another giant that roamed these plains. This one was a rhinoceros ancestor, but it was so massive it approached the size of the great sauropod dinosaurs that had preceded it by tens of millions of years. This was Indricotherium, a 20-ton herbivore so massive that a modern rhino would have been like a chihuahua next to it. It had a long, graceful neck, and you can imagine it browsing on the tops of the tallest trees, a kind of prehistoric, rhino-like giraffe. You just have to hope it wasn't a picky eater. That's a lot of food you have to bring with you on a very, very long road trip. The rhinos of this era were a different breed altogether. You might have seen the 4-ton Elasmotherium, a woolly rhinoceros, with a single, immense 3-foot-long horn on its snout. This creature, with its magnificent horn and shaggy fur, would have been an intimidating sight. You can almost feel the presence of this animal, a quiet, prehistoric giant, whose sheer size and terrifying horn would have been enough to make any sane creature walk in the other direction. It is a fascinating and truly quirky tidbit that some historians believe this immense creature, with its magnificent single horn, may have been the source of the unicorn legend. People would have seen its fossilized remains or perhaps caught a rare glimpse of it in the wild and imagined a magical creature, a kind of majestic one-horned horse. It's a lovely thought, isn't it? The real world being so much stranger and more beautiful than a fairy tale. Of course, the Elasmotherium didn't live a fairy tale life. Its thick, shaggy coat of fur made it a prized target for a certain kind of clever, two-legged predator that was beginning to spread across the globe. Of course, where there are herbivores, there are carnivores. And the king of the carnivores was a terrifying 1-ton meat-eater called Andrus arcus, whose skull, a single enormous fossil found in the Gobi Desert, is all we have to go on. A classic, open scholarly debate exists over what this creature looked like. Was it a wolf-like creature? Was it a hulking, bear-like beast? No one knows for sure, but based on the sheer size of its jaws, we can imagine it was a beast you would not want to meet in a dark alley. Its jaws were so immense that some scientists believe it supplemented its diet by biting through the hard shells of equally gigantic prehistoric turtles, which is a very polite way of saying it ate giant shelled things as a side dish. I mean, can you imagine trying to order takeout from that guy? "I'll take the giant turtle, please." and make it snappy. The land wasn't the only place to find giants. You would have had to watch your step, or rather your paddle, if you were an early aquatic mammal. In the oceans, a 60-ton whale ancestor, the Basilosaurus, patrolled the oceans, a massive, serpent-like whale that would have dwarfed any modern-day orca. Oh, it was a terrifying, long creature that would have been a sight to behold. But it wasn't even the biggest whale. The record for the largest mammal ever goes to the modern blue whale, which can grow to be as much as 200 tons. It's a funny thought, isn't it? That for all the incredible creatures we've talked about so far, the biggest one is still swimming around in your own world, quietly munching on krill and making sure you feel very, very small. But my favorite of all the marine giants is a creature that persisted well into the historical period. The Steller's sea cow, a 10-ton kelp-munching dugong ancestor, was so big and so gentle that it was simply unafraid of humans. It lived in the cold waters of the northern Pacific, and you can just imagine it. A giant, placid, underwater cow munching on kelp, utterly oblivious to the danger that was beginning to emerge on the land. It was a kind of a beautiful, dumb, prehistoric manatee, and we'll get to its tragic story later. You can just picture it, can't you? A big, blubbery cow just floating there, thinking, man, this kelp is great. Nothing could possibly go wrong. Famous last words, right? The Pleistocene was a world of these and other magnificent giants. In Australia, you had the rhino-sized wombat-like Diprotodon and the giant Goanna megalania, a 2-ton lizard that would have made a modern Komodo dragon look like a house cat. The land was a bestiary of incredible, unforgettable creatures. But their reign, for all its majesty, was about to come to a very sudden and very final end. This end came not from an asteroid or a volcano, but from a different kind of force, a new and in many ways more frightening kind of predator. The end of this epoch, the end of the last ice age, was marked by a wave of extinctions that remains a subject of intense scientific scrutiny. You see, the cause of the megafauna extinctions has been a decades-long debate, primarily centered on two competing hypotheses: a climate-driven extinction versus an overkill extinction caused by human hunting. This is a topic that historians and scientists still argue about, and it is the story of that debate and the answers we have begun to uncover that will be the subject of our next chapter. The end of one kind of giant gave rise to another, and the end of those giants was the first time that a single species would be the driving force behind a planetary-scale die-off. A terrible new chapter was about to begin, and it was being written by us. You've seen the last of the ancient giants now, the woolly mammoths, the giant wombats, and the massive rhino-like beasts that roamed the cold, magnificent world of the last ice age. Their reign was a testament to the power of a world that was on the mend, a testament to life's ability to find a way even in a world of ice and unforgiving cold. But their reign came to an end, an abrupt and in some ways incredibly puzzling end, because this time the end was not brought by a planet-sized shockwave or a slow, agonizing planetary fever. This time the end was brought by something entirely new. A new variable was introduced into the equation of extinction, and it had a spear in its hand. The cause of the megafauna extinctions. The disappearance of these great beasts at the end of the last ice age has been the subject of a long-running, decades-long controversy. It is a scientific debate, so contentious, so full of competing data and conflicting hypotheses, that it can feel a bit like watching a very high-stakes tennis match where the ball is the fossil record. And you, the observer, are a tiny, fur-covered spectator watching as two opposing sides volley their theories back and forth. On one side, you have the climate change hypothesis. It's a very reasonable, very logical theory. It says that the megafauna were simply unable to adapt to the rapid global environmental shifts at the end of the last ice age. The world was getting warmer. The glaciers were retreating. And the vast periglacial tundras, that cold, magnificent world that the mammoths and woolly rhinos had adapted to, were being replaced by immense, sprawling forests. It's an ecological turnover on a massive scale. And for a species that has spent millions of years learning how to survive in the cold, a sudden, permanent change to a much warmer forested world would have been an extinction-level event. The supporters of this theory have a very compelling question. They say if the extinctions were due to climate change, then why did these large mammals survive previous glacial, interglacial transitions, only to vanish at the one when human hunters were present? It's a great question, isn't it? A bit of a checkmate move, but of course there are some great counter moves. But for now, you just have to sit there, a silent, furry mammal yourself, and watch as this new, powerful argument takes the stage. And that argument is the overkill hypothesis. It's a much more sinister and, in many ways, much more terrifying theory because it puts the blame squarely on a single species, ours. The overkill hypothesis, first proposed in 1966, suggests that as humans migrated out of Africa, they arrived in new continents and islands where the native megafauna had no experience with a sophisticated, cooperative predator. This new pressure, combined with their slow life cycles, led to their rapid demise. And the evidence for this theory is, in its own way, incredibly compelling. The first piece of evidence is a stunning temporal correlation. It's a bit like watching two trains arrive at the station at the exact same time. The archaeological record shows that the wave of megafauna extinctions on a continent seems to coincide almost perfectly with the arrival of humans. You can look at Australia, for example. The first humans are believed to have arrived there around 50,000 years ago, and the extinctions of the giant wombats, the immense lizards, and the rhino-sized marsupials began to happen right around that time. It was a kind of synchronized vanishing act. A similar pattern is seen in the Americas, where the extinctions of the mammoths, mastodons, and giant sloths occurred around 13,000 years ago, right around the time the first human hunters, the Paleo-Indians, are believed to have arrived. It's a pattern that is repeated on island after island from Madagascar to New Zealand. The further you get from Africa, the continent where humans and megafauna evolved together for millions of years, the higher the rate of extinction. The theory is that the megafauna in Africa, having had millions of years to get used to a very smart and very hungry predator, had learned how to avoid us. The megafauna in Australia and the Americas, however, were in a very real way unaccustomed to humans. They were, in the words of one scientist, a bit like a big, dumb, delicious Thanksgiving turkey, just standing around waiting for the carving knife. It's a bit of a gentle joke, a bit of black humor, but it captures the essence of the argument. But like with all great scientific mysteries, the story is not a simple one. The overkill hypothesis, as clear and compelling as it sounds, is not without its powerful counterarguments. One of the greatest of these is a quirky fringe tidbit about the very nature of human hunting. You see, some scholars argue that early humans were not specializing in hunting megafauna. They were generalists, and an analysis of optimal foraging theory suggests that hunting a mammoth was a lot of work for not a lot of caloric return. It's like trying to get a full meal from a vending machine that only sells a single tiny bag of stale chips. It's just not worth it. So if we weren't specializing in hunting megafauna, how could we be responsible for their extinction? The answer, of course, is that a small amount of hunting, when done to a species that already has a slow reproduction cycle, can be devastating. The debate has often come down to the very small, very granular details of archaeological sites. One of the most famous of these sites is Cuddy Springs in western New South Wales, Australia. For a long time, this site was a powerful counterpoint to the overkill hypothesis. Scientists found a treasure trove of megafauna fossils, including the rhino-sized diprotodon, in the same sedimentary layers as stone tools. This was seen as unequivocal evidence that humans and megafauna had coexisted for a very long time, which would have contradicted the Blitzkrieg model, the idea that humans just wiped them out in a single rapid wave. The scientific consensus at the time was that this site showed a long overlap, a kind of peaceful coexistence. It was a classic case of an open scholarly debate, with the two sides, the overkill proponents and the climate change proponents, using the same data to argue completely different points. But as with so many scientific debates, the technology changed, and with it the story. Newer, more accurate dating methods showed that the artifacts and the megafauna fossils at Cuddy Springs were not from the same period. They had been mixed together over thousands of years by the movement of soil and water long after the great animals had died. The site, which had once been the poster child for peaceful coexistence, was now just a normal, fossil-rich site. It no longer provided evidence for the late survival of the megafauna. It was a kind of scientific plot twist, a revelation that reignited the argument that human impact was the most likely extinction driver. As you can see, the debate is not as simple as an either-or. It's a complex, multi-layered puzzle. It is possible that the megafauna populations were already receding due to climate change before humans ever arrived. It is also possible that the arrival of humans was a kind of final, decisive blow to a world that was already teetering on the edge of ecological collapse. A recent study using a new form of genetic analysis has provided some new clues. The study found that the inability of climate to predict the observed population decline of megafauna, especially during the past 75,000 years, implies that human impact became the main driver of megafauna dynamics. So while climate may have been a factor, it seems that we, the two-legged predators, were the decisive force in this final, tragic chapter for the giants. The story of the Pleistocene extinctions is a microcosm of the scientific process itself. It's a narrative of competing ideas of new evidence and of a slow, incremental, and often contentious march toward the truth. It shows us that in the grand drama of planetary history, even a single, seemingly insignificant variable can be the one that turns the tide. It shows us that in the story of extinction, we are not just observers. We are in a very real way the main character. And the next chapter of the story is not a debate at all. It's a tragic, undeniable record of what happens when a single species becomes the agent of planetary-scale extinction. It is the story of our own last breath and the final, undeniable proof of our terrible power. You have seen the arguments now, the elegant and frustrating dance between two powerful theories. You have seen the evidence for the overkill hypothesis, a compelling timeline that shows a direct correlation between the arrival of humans and the disappearance of the giants. And you have seen the counter-arguments, the evidence for climate change, the idea that the planet was changing so fast the megafauna just couldn't keep up. The debate over the megafauna extinctions, over the fate of the woolly mammoths and the giant kangaroos, has long been a point of contention. It's a classic, open scholarly debate, a puzzle that seems to have more pieces than it has places to put them. But here's the thing about this debate. It's a stepping stone, a bridge between the ancient impersonal cataclysms of the deep past and the very real, very personal tragedy of the modern world. Because as we move from the prehistoric past to the historical record, the debate simply ends. The story becomes undeniably tragically clear. And in this final chapter for the Giants, we are not just a character. We are the main villain. You are no longer in the Pleistocene, that world of ice and unforgiving cold. You are now in a time that is much closer to your own, a world of sailing ships and exploration. And you are standing on the shores of a remote, unforgiving island in the northern Pacific. The air is cold and damp, and the wind carries the briny scent of the sea. It's the year 1741, and a small band of European sailors has just made a startling discovery. They have stumbled upon the last living population of an incredible marine mammal that you've already met, the stellar sea cow. This creature, as you might recall, was a massive 10-ton gentle giant, a close relative of the modern dugong, a kind of peaceful, kelp-munching manatee that was so enormous and so docile that it was, in the words of the sailors, none too bright. You can almost picture it, a big blubbery cow just floating in the cold water, munching on kelp and looking up at the sailors with big, unblinking eyes, completely and utterly without fear. What a wonderfully quirky and heartbreaking tidbit. This creature, a living relic of the Ice Age, a survivor of countless changes, had managed to persist in the remote northern waters, a kind of biological ghost of the past. But its luck had run out. It had met a new kind of predator, a predator with no natural check on its behavior, a predator that saw not a majestic giant but a free, immense supply of meat and oil. And so the sailors, having found this easy prey, began to hunt them. They were a small band with pre-industrial technologies. They had no advanced whaling ships, no massive harpoons, just their cunning and their greed. And in a terrifyingly short amount of time, a period of just 27 years from its discovery, in 1741 to its extinction in 1768, the stellar's sea cow was hunted to oblivion. Its last breath was taken not from a volcanic eruption or a cosmic strike, but from a human spear. This is a story that cannot be debated. It is a simple, tragic, and undeniable record of the power of a single species to cause the extinction of another. It shows that even a small band of hunters using rudimentary technology can be a planetary-scale force of extinction when they are targeting a species that has no fear of them and a painfully slow reproduction cycle. It's a lesson that is not found in the deep fossilized past, but in the all-too-recent historical record. But the story gets even more staggering. You are now in the 1800s in the vast wild forests of the United States. You look up and the sun is gone. Not because of a volcano or an asteroid, but because of a bird. A bird so numerous that its flocks were said to darken the sky for days on end. This is the passenger pigeon, a species so abundant that in the early 1800s there were an estimated 3 billion of them in North America alone. It was an ornithological sight that is almost impossible to imagine. A living feathered cloud that blotted out the sun, a kind of majestic, living shadow that would have passed over your head for what would have felt like an eternity. It would have been a profoundly uncomfortable sky to live under, a sky filled with the fluttering of wings and a constant chirping roar that would have made any normal bird song seem like a faint whisper. And yet this species, with its unimaginable numbers, went extinct in less than a century. The last known passenger pigeon, a bird named Martha, died in the Cincinnati Zoo in 1914. The causes of its disappearance are a tragic and once again an undeniable story. The species was hunted to oblivion by commercial exploitation, with hunters netting and shooting them by the hundreds of thousands for their meat. At the same time, the vast eastern forests, which had once been their home, were being cleared for farmland. The passenger pigeon, which had once been so numerous it could blot out the sun, was now just a memory, a cautionary tale about a bird that could not escape the twin forces of overhunting and habitat destruction. It's a terrible, beautiful irony, isn't it? The very species that could literally block out the sun was powerless to stop the one species that would one day control it. These historical extinctions of the Steller's sea cow and the passenger pigeon are not just sad stories about animals that we lost. They are a profound and terrible transition in the story of extinction. They are the final, unassailable evidence of the power of a single species to become a planetary-scale force for extinction. And they provide a direct and sobering link to the world you are living in right now. Because the end of the last ice age, the die-off of the great megafauna, with its messy, debatable evidence and its conflicting theories, was a direct precursor to the modern world. The debate is over. Humanity has become the most powerful and destructive author in the story of life on Earth. There is a widespread and undeniable scientific consensus that we are currently living in a sixth mass extinction event, a period of unprecedented biodiversity loss that is called the Holocene extinction. And this extinction is different from all 5 that came before it. This time, the cause is not a comet, or a volcano, or a sudden planetary shiver. This time, the primary driver is us, our unsustainable use of land, water, and energy, our relentless expansion, and our disregard for the very ecosystems that we depend on has become the single greatest threat to life on Earth. It's a bit like living in a house and slowly, methodically, tearing down all the walls and doors, all the while complaining about the drafts and the lack of privacy. The scale of this modern die-off is staggering. The current species extinction rate is estimated to be hundreds, even thousands of times higher than the natural baseline rate. That's the rate of extinction that would happen if we humans were not around. The primary drivers are simple and familiar. The first is habitat destruction. Over 40% of all land on the planet has been converted for food production, and agriculture is responsible for 90% of global deforestation and 70% of freshwater use. It is a kind of planetary-scale, scorched earth policy, a process that is devastating the species that live in these places by completely altering their habitats. The second is climate change. We are pumping greenhouse gases into the atmosphere, causing temperatures to rise, and in doing so, we are creating a world of more frequent and intense storms, droughts, and heat waves. This puts immense pressure on ecosystems that are already stressed by habitat loss, and it creates a deadly 1-2 punch that has already pushed many species to the brink. The history of extinction, from the great dying to the end of the dinosaurs, has shown you the profound fragility of ecosystems in the face of rapid, profound environmental change. It has shown you how a single, powerful perturbation can set off a chain reaction that unravels the entire intricate web of life. But now, as you return to the present, you realize that the primary perturbation is not an impersonal force of nature. It is a single, self-aware species. We have become the most powerful geological force on the planet, capable of changing the atmosphere and reshaping the land at a speed that is hundreds of times faster than natural baseline rates. Unlike the trilobites or the non-avian dinosaurs, we have the capacity to understand the mechanisms of our own impact. The lessons of past extinctions, the catastrophic consequences of rapid change, are now a stark and urgent warning. The question is no longer whether a meteor will strike or a volcano will erupt, but whether we, as the planet's newest agent of extinction, can learn from the last breaths of the prehistoric giants and choose a different path. The end of the story is not a conclusion, but a quiet, sobering call to awareness. The final word on this, the sixth extinction, is one that has yet to be written, and the hand that holds the pen is yours. And so our long journey through deep time comes to a close. You have traveled through fire and ice, through light and darkness, through worlds both alien and familiar. You have seen the last breaths of the prehistoric giants, and in doing so, you have come to a deeper, more profound understanding of the world you inhabit. All of these stories, these whispers from the deep past, are not just academic curiosities. They are reflections of a living, breathing planet that is constantly in motion, a planet that is both a creator and a destroyer. You can now rest for the grand drama of extinction, with its immense cast of characters and its planetary scale special effects is over for the night. The stories are told. The lessons are clear. We are living in a moment unlike any other, a moment of profound vulnerability, but also one of profound power. The choices we make now will echo through the ages, not just for us, but for every living thing that shares this fragile planet. The past is a map, a guide that shows us the way forward, a silent testament to the catastrophic consequences of turning a blind eye to the planet's subtle yet urgent cries. There is a final quiet question that hangs in the air, a whisper from the past, a question that only you can answer. Can you, now that you know the story, choose a different ending for it? It's a question that we are all in our own way trying to answer. And as you close your eyes now, as the last of the imagery fades from your mind, you can take a small comfort in the knowledge that your own story, your own part in this great ongoing narrative, has only just begun. Sleep now, sleep, sweet dreams,